I would now like to invite on the stage Chander Shahdadpuri, Senior Technical Director, and Gerry McFadden, BIM Manager at the WSP Group, to share a case study on one of their prestigious projects, BIM for Stadium Projects. Please welcome our guests.
Good afternoon, ladies and gentlemen, and thank you, Autodesk, for giving us the opportunity to talk about our project, which is a case study on the Hazza Bin Zayed Stadium project, which we at WSP are very proud of and have delivered recently. There was an extensive use of BIM on that project, and the project is based in Alain. So if you ever go to Alain and take the airport road off on the left, it comes on your left. We used Revit and of course Navisworks extensively on the project, and given the tight time frame that we had, which you will see shortly, it was almost impossible to deliver without these powerful tools at our disposal. There was also a very strong collaboration between various disciplines, including WSP and other consultants with whom we collaborated on the project. And hopefully, at the end of the session, you will understand a little bit about the design of the stadium itself, how Autodesk, used Revit to sort of collaborate with other teams and to improve the model and the designs as well, and also how Navisworks was used. And that will be explored in a lot more detail by my colleague Gerry McFadden. So, who are we? WSP. We are one-stop shop engineering consultants, one of the leading professional services in the world. We are spread across 5 continents, 35 countries, and now 39 countries. I'm sorry, and now 31,500 employees across the world. And our services include building structures, infrastructure, vertical transportation, fire life and safety, security, amongst many other engineering disciplines. The image that you see there is an image of the Hazza Bin Zayed Stadium project. So really, like I said, the project was based in Alain, and it was a combination of a concrete shell system with a steel overarching frame. And it had a fairly complex geometry, and it had a complex geometry for a particular reason, apart from the aesthetic look of it, which we'll explore in a bit detail as we go further. These are some of the comments on a few websites. Ultra fast track FIFA standard stadium in Alain, and it's been described as a remarkable feat of engineering in some of the websites. So key facts about the project: 25,000 seater stadium. It's the home for the Alain Football Club. It also has, apart from the main stadium, the flagship stadium, 2 other buildings, the sports center and the commercial center building. Contract value close to 800 million dirhams. The main contractor was BAM International, and the WSP and the other consultants were all part of the design and build team, which were based on site as well. And client AFAC Holdings, client's engineer AC Harris, and the client's structural engineer's reviewer was GHD. We also had the original concept structural engineer, and from whom we had taken on the design once we became part of the DNB team. It had a very interesting facade, which you probably see in some of the images as you move on. But the facade was what we call as a moving facade, and it was inspired by the palm bowl, which is. If you see here at the left, you have an image of a palm tree, and if you go to Alain, you'll find many of these, palm trees dotted all over. And if you look at the palm tree closely, you've got a palm bowl, which is, the piece at the middle, which is what the trunk is formed of, and that inspired the idea of the facade. Except that it was a moving facade, which means that the facade can be sort of adjusted to suit the lighting and the daylight requirements as the day progresses and the match goes on. And then what this does is provides maximum shading, obviously, to the people who are attending the match. Just to give an idea of what was the time frame. This is how the site looked in August 2012. That's an image in October 2013. 16 months flat, completed, delivered, and also value engineered as we went on. So this is a short introduction from myself, and what I'll do is hand over to Gerry, who will come and talk the more relevant aspects related to BIM, and then go through it more. Thank you very much indeed.
Afternoon, everyone. Hope everyone's doing well. Had a nice lunch. So I'm Gerry McFadden. I am the BIM manager at WSP in the Middle East. As Chander gave us a pretty good introduction of the project there. Very stylistic building, in my opinion. Really interesting one to work on. But it did have its certain challenges as well, as we'll see as we go through it, yeah? So just to go over some of the project goals that we were looking at on the project. So as Chander mentioned, fast track delivery, ultra fast track, 14 months from starting groundbreaking to getting the actual structure finished. This was one of the main drivers of the project. Our client, it was a design and build project. Our client contractor came to us looking for someone who could deliver it in that time frame. Which was great, but certainly a big challenge. So some of the main things that we were looking for in the project, some of the goals: very cost-effective design, high-quality design. We had to be able to construct this thing quickly. We didn't want the guys getting to site, finding problems with the design, having to go and rework it. So what we came up with was it's a very detailed model, which we could extract highly detailed drawings from, to make sure that constructability was taken into account, as well as the efficiency of the design. So how did we achieve this? Number one, we've got an excellent group of people working for us: engineers, Revit technicians, drafters, etc. So number one, how did we achieve it, was the people working with us. What tools did we achieve it? What processes? Was BIM played a major part in actually delivering this project. I couldn't see any other way to do it and have the confidence that the design was accurate and we could pass it to the contractor, and he could have that confidence that he can build the thing without major problems. Some of the points about BIM that are quite pertinent to this design: faster understanding of the geometry, which is quite unique in stadiums, which we'll touch on in a moment. Faster ability to produce the models, the drawings. We can cut sections instantaneously through this stadium. It really kind of engenders, things like design options. For the contractor, it's very different in a design and build contract. That we have a very close association with the contractor. He's our client, so he might see things in the design as we're developing it. He might think, well, can we try this? This may be a more efficient way to construct it. Then using tools like Revit, which is excellent for this type of work, we can look at kind of what options can we do, what's the most efficient design, and also very importantly for the contractor is constructability. Yeah, that's number one. There's no good having this fancy, all singing, all dancing Revit model if you get to site and, it's not going to be constructible. So very important. Okay, some of the challenges. As I've mentioned, is design and build with a contractor. Especially a challenge as the contractor was already on site, so we get bought into the process at a time. Contractor's really set up on site, he's ready to go. That obviously brings its own challenges with it. So the fast track delivery, we actually took over the tender stage models, which were developed by another consultant. And they had done a good job getting the Revit model and the drawings extracted from that and CAD, etc. For the tender stage. But that and a challenge is, it is a challenge taking over someone else's design because everyone does things differently. And also we found the tender stage model was quite basic, and it had some things that we had to address even before we started working on it to get it to a stage where we can actually start refining the design. The first thing we did was value engineering, so there was quite a lot of rework on the model, which was, you know, tough in itself. We had the guys based on site at the stadium, whereas our design team was in Sharjah. So again, that brings a different dynamic. You know, how do we get the information quickly across, etc. And as I mentioned before, we needed to be very quick on our feet. Different options. What can we do with this? How can we turn it around quickly? Yeah. Okay. As I mentioned, we took over the Revit model from another company who had developed the tender stage drawings, and it was good. They'd done their part. But when we started looking at the model, you know, you find that because something is done in Revit doesn't necessarily mean it's ready for a different stage of development. So when we started looking at the package that we had, we found some of the model had been done accurately, some of it had been modeled, some of it was 2D annotations. So again, it gave us a bit of a challenge as we wanted to construct the full thing, 3D, make sure that model was the kind of one point of truth where we could extract information from, be it quantities, drawings, etc. Even certain things like, you know, if you look at a 2D set of drawings, some PDFs, okay, this looks great, get the Revit model, and then we noticed things like the tags had not been used, so they'd been using text. Again, we want to get that model to a baseline where we can have confidence in it. If we change a beam size or change a slab level, you know, it's going to reflect it using the intelligent tags. Navisworks we used extensively to actually review the original models, go into the model, see what needs to be changed on it, find out any problems with it, which we'll touch on shortly. Okay, just a couple of slides on stadium geometry. Just kind of show of hands, has anyone ever kind of worked on a stadium using Revit? No one? Okay, that's good. So you can't correct me then, that's all good. Okay, so stadium geometry, I mean, you know, you look at these things and, you know, until you actually start looking at the kind of a bit closer detail, you know, you might not realize how difficult it is. But something that I always find amazing is that, you know, we've been building things, human race has been building sort of stadiums for thousands of years. The only difference is now that we have got fantastic tools like Revit and Navisworks to help us actually build that virtual model so we can test it, walk through it, etc. And it never fails to amaze me that, you know, 2,000 years ago in Rome, they were building these things, very similar type of things, you know. So it makes it even more fantastic that they built these things so many years ago without all this high-tech stuff that we use today. But still, it's pretty challenging, stadium geometry, yeah. As I said, some of it looks straightforward. We've been building them for thousands of years. One thing about stadium geometry, which is different from quite a lot of kind of projects we do, and just to, I don't know if we mentioned this, we were doing the structural model for this, yeah? But basically, from all sides, it could be lozenge shaped, it could be pill shaped, but you have this terracing of the seating, everything is coming in from all different sides, you know, which sounds straightforward enough. But then we have all of these access points from different levels. You know, the people come through here and they have to spread out. It's quite different. On this project also, the outside of the stadium was actually kind of raked. So, you know, every level, pretty much a completely different set of structural plans. One good thing about stadium geometry is made for BIM. You know, we can look at these things instead of trying to work out from 2D drawings. You know, anyone who's worked in a normal project knows that using Revit is just night and day above, you know, 2D CAD. And this is really comes to the fore when we look at, wouldn't say complex geometry, but irregular geometry such as stadiums, yeah. So just to kind of highlight that a bit. So you can see the kind of sloped seating here. We obviously had 4 sides of the stadium. Each one, different levels, different length, different kind of radius. So it's quite an interesting one. These things here, which are the access into the stadium, were actually some of the most complex things to model. And the guy who modeled it is here with us today, Sajivan, and I saw quite a few occasions he's pulling his hair out trying to model this stuff. But it is really the only way to do it is using the 3D geometry, cutting it, taking the sections, working through it, and it really is the only way to do it. Again, this sort of thing looks straightforward, but to actually try and produce these things to make sure the levels are correct, you know, the wall heights are correct, there's a lot of actual work in this. Okay, what we did use quite a lot of was bespoke Revit families, so there was quite a lot of in-place Revit families, just because certain areas there was very little repetition. So we found that we had to do quite a lot of in-place families, which anyone who uses Revit will always say, you know, no in-place families, but certain projects, we can try and we can make things rationalized so we can do some parametric families. But at the end of the day, you know, if we've got all of these unique details, quickest way to do it, obviously it's a fast-track project, is to do some in-place families, yeah? Which again has its own challenges. And a lot of this stuff looks simple. This is a raker beam that we're looking at here, and this is what actually sits underneath the terrace seating and supports all these seats, yeah? Obviously the drawings that we produced for this from the model had to be very accurate, very tight tolerances, so the contractor has got that confidence that when he starts building this stuff on site, precast seating, etc., that, you know, he's not going to find that things don't fit. He's going to be delayed. You know, you get guys sitting in the canteen, you know, so that can be very expensive. So we really did try to model things accurately on this. Again, just some sort of in-place families that we've done here. Again, a lot of kind of voids, a lot of irregular shaped beams, and it is just really, it took the guys, it was quite labour intensive to do the models, but you know, the guys worked through it, and you know, the end product was, you know, just incredible, very, very good. Okay, just to kind of demonstrate the high level of detail that we have here, this is an area underneath it's on the concourse, but it's actually underneath the terrace seating. So you can probably see, you know, the irregularity of this project here. You know, you've got beams coming from all angles, different heights. The big raker beams, again, are supporting the stadium seating. Those in themselves had to be very accurate to make sure that, you know, when they did this on site, they weren't going to install the seats and find that they're different lengths, or different heights, rather. So I've mentioned a bit about Revit, rather. So we used Revit structure extensively on this. It was a very detailed model. We didn't do much in the way of CAD or any kind of 2D details as such. We really tried to utilize the benefit of the 3D model. As I mentioned before, we used Navisworks extensively on this. So we had architecture, our own structural model, MEP was modeled, and you can see in the background there the actual roof structure, which was modeled by another consultant. But by using that, we could bring all these models excuse me, together and actually get the whole picture of the project. So again, we used Navisworks primarily for coordination. It gives you a higher degree of kind of confidence for design reviews, etc. Again, we're looking at one of the external faces of the building here. Again, try to get all these stairs, etc., to tie into the different access levels, quite challenging. The architecture also was quite irregular, same as the structure, obviously. So we had to use Navisworks to try and get these things correct. I've put on this slide for tricky interfaces. I mean, there's nothing here that was difficult, it's just time consuming, yeah? So each one of these interfaces with the structure and the architecture, you can see the kind of boxes at the top here. Again, we've got the structural roof coming in. It was the only way to really make sure the design was correct was by using Navisworks. And again, just another snapshot of some of the coordination areas there. So we use Navisworks when looking at the other consultants' models. What we also do quite extensively in-house in WSP is use Navisworks as a collaboration tool. So even if we've got, you know, if we've got some guy working in Qatar someone working in Dubai or Sharjah office, we can exchange Navisworks models if they're working in different parts of a building, and it saves us this whole kind of 2D marking up drawings, scanning it. 2D is just such an inefficient way to work. This is a couple of snapshots of the kind of early design model, and we had a full set of drawings for this. And if you looked at the drawings, they looked okay, Yep, looks fine. But once we actually put that into Navis, the Revit model, you can walk through it, and in 2 minutes you can say, okay, that's not right, that's not supported. It's just such an efficient way to work, and it's such a time saver on these fast track projects. So a couple of examples there. So we're looking at one of the raker beams on the left-hand side here. So we can see the raker beam is coming up, sitting flush with the column. So when we saw that in the design, pretty difficult to see it from the 2D drawings. So we then decided we needed to add a corbel to the column there to actually support the raker beam. Again, the other image on the right-hand side, we can actually see there's some of these massive raker beams which are taking the weight of all the stadium seating, and there's no support on it, So very quickly, by looking at the early stage model, we can identify these major things and say to our client, the contractor, this is missing and this is missing. We have to look at a detail for the corbel to support the raker beams, etc. So very powerful. Again, even things like columns, beams not connected, and it could mean a redesign of the beam. If we've got a beam that's shallow, we've got a deeper beam that's coming in, and for some reason that beam has been missed or the connection is not correct, then we could have to redesign that, So this is the sort of stuff that we can't leave until it gets to site, So the days of kind of issuing 2D drawings, give it to the contractor, he gets to site, does the RFI, probably makes a claim. This is the sort of things that we're trying to, improve in our industry so that we're all on the same page and, smoother, streamlined process, And as I said, Navisworks, for me, if I'm sitting working on Revit model, I very often just export to Navis, have a look at it in Navis, and the things that you will see in Navis that you won't spot even on a Revit model is pretty incredible. Again, just another one here. So we're looking at constructability review. So do we need to look at this? The contractor was using Navisworks extensively. So they would look at the model, come back to us, we think we can do this more efficiently, and then we'd look at the design model in Revit, we'd revise it, etc. As I mentioned previously, the roof structure was done by another consultant. So very important to get the interfaces right between our concrete model and the roof model. So we used Navisworks and Revit, brought these together, geo-referenced the points, and again, it just gave us that level of confidence that when we issued the drawings, that we know when the guy goes to fabricate the roof, when the contractor's looking at the embedment details, he's got an accurate point where he can do the base plates, etc. And again, it's just given that, that confidence that the design is correct. And so we know when they come to place this stuff, on these massive cranes, that they're not going to have it sitting here and the column sitting there. Okay, it's just a quick project fly-through. So Hazza Bin Zayed Stadium, Al Ain, not too far away. Okay, it's not a kind of accurate 4D, as anyone will see. We've got columns going up before beams, etc. But you'll see the kind of level of detail we went within the model. So we pretty much modeled everything. You can see the outside is sloping out. So pretty much every level on this building was a unique set, a plan. There was very little repetition. You can see the terracing going in there. I'm just doing a fly around here. This is only the structural model, so we don't have the architecture on here. You can see the roof coming in. Again, it's a kind of early design stage model that we did for visualization. So I think it gives you a flavour of the stadium. The actual roof is kind of inspired, you'll see in the next picture, by the kind of traditional Arabic headdress, the kind of white flowing, it looks better on the architectural image, but you will see that. And as Chander said, the external facade is kind of sort of palm trees. So it's a great project. There's a lot of kind of local heritage tried to be built into it. One thing which is great about Navisworks, which I love, you can actually go inside the building, turn on the little man, you can run out in the stadium, imagine the crowd in your head. Obviously wanted to be a football player, but okay, let's go to the next one. Okay. Sorry, let's close this one. So it's been mentioned, or kind of got mentioned in a couple of awards. So for the iStruct Sports Leisure category, it got commendation, and for the Middle East Architecture Leisure category, it was shortlisted. I mean, again, you can see the image there. These movable panels that Chander kind of touched on previously, they've actually got a couple of LED lights in it. So at night, you know, they can actually change the colour of this thing as it goes round. You can kind of see the kind of the roof structure there. It's a fabric structure. It's very nice. All of the spotlights are actually mounted on the roof structure, so there's no need for these big ugly spotlights at the corners. It's a very nice, prestigious project to work on. And this was the inaugural match, so I think we started, what was it, October 2012, was it, John? So, you know, very short time from actually starting on site, getting it built, you know, and then there was Al Ain FC versus Man City, 15th of May 2014. Not sure what the score was. I suspect Man City may have won, but I'm not sure. Okay.